こんにちは。こんにちは。聞こえますか？宮本さんの声が聞こえない。ミュートになってるんだ。すいません。解除します。
はい、ごめんなさい、ごめんなさい。私がミュートでしたね。はい、こんにちは。すみません。
こんにちは。ありがとうございます。
ありがとうございます。ご招待ありがとうございます。ご招待いただいて。
すごい楽しみ。ずっとお呼びしたくてですね。ただ、オックスフォードにいらっしゃると知ってたので、ちょっとタイミング的になんか難しいなと思ってたところ、理研にいらっしゃるということで、すごい楽しみにされます。はい。ですね。そうか、まだちょっと時間あるんですけれども、一度、スライドの共有を少しさせていただいてください。で、はい。一応、今回は、終わった後に公開してもよろしい大丈夫ですか？
でき次第ですね。
基本的に質疑応答自体は、切って自由に喋ってもらえるように、しているので、なんていうんですか、トークのみを今は、公開して。
わかりました。はい、ちょっと場合によって編集していただくかもしれ
ない。大丈夫です。結構永井幸恵先生がいらっしゃった時は編集して一部カットしたりとかもしたので、そういうのも全然もう僕も編集もやるようになった。
もしかしたら取り直しでまた送るかもしれない。完全に違うトークをみたいな。
入れ替わってる。
入れ替わってる。そうそうそう。
いや、でも、はい、
すみません。お見せすればいいですね。
はい、共有のボタンが下にあると思うんですけど。
これですよね。はい。これで、どうでしょう。これで今、全部の画面が共有されてるので、これでいいんですよね。
はい、大丈夫だと思います。はい、今、バッチリ見えてるので、多分大丈夫だと思います。ありがとうございます。はい。じゃあ、そうですね。一応、今回、4時から始める予定なんですけれども、大体皆さん少し5分ぐらい遅れてくるので、その時に僕のというか、コンシャスネスクラブを一応紹介して、でそこから僕が宮本さんをご紹介すると、スピーカーを紹介するという流れでやっています。はい。なので、そうですね、ちょっと5分、ちょっと10分間ぐらい、空きの時間があるかなと思って、待機していただければと、思います。
時間としてはどれぐらいで？
一応、1時間ぐらいで、トークは切ろうかなと思ってはいるんですけれども、ちょっと伸びる分には全然構わないです。
多分1時間より短いんじゃないかなという感じでもいいですか？そしたら
全然もちろん、はい。ディスカッションとかも、取ってですね。あとちょっと、トークの後に皆さんちょっと疲れると思うので、なんか、ちょっとだけ休憩時間とかみたいな。
もちろん、そっちの方がありがたいです。
はい。やっていく。ちょっとお茶とか水取っていただければと思っています。はい。じゃあ、はい。他に何か。
じゃなくて、英語ですよね。
英語で、はい。英語でお願いしています。
質問はどちらもあるって感じですか？質問も。
いや、一応、英語でお願いしてるんですけど、そうですね、確かに。まあでも、英語でちょっと皆さん、
どんなことがあっても英語で喋った方がいいってことですね。つまり、だから、これ日本語の方が多分伝わりやすいなって多分、質問で思った時も、基本的には英語の話者の人がいるっていうことですよね。
そうですね。まあ、ただ、まあ、別に止めることは僕はできないので、なんか日本語で聞くときも多分あると思う。それの時はもう答えていただければと思います。はい。まあそうですね。できるだけなんか本当はですね、学生さんに来てもらって、今いろいろ喋ってもらうっていうのが今後期待していることなんですけど、なかなかちょっとハードルが高いのかなという気もしまして、はい。ちょっと、はい。でも、ちょっとハードコアにちょっとやらせていただきたいです。
トークの間は基本的には質問はされないということなんですか？それか。
いや、それも一応大丈夫なんですけど、宮本さんの、
それで
好きなようにやっていただくのが一番いいです。はい。
全然構わないので、質問していただいた方が多分いいかもしれない。
途中で質問、いただく方もいらっしゃるんで、
はい
全然大丈夫です。はい。
わかりました。
目安として僕たちもその時間を設定してるだけなので、
はい、わかりました。
はい、すいません。じゃあ、これでよろしくお願いします。
よろしくお願いします。
はい、ちょっと順次人をちょっと今入れていこうと
はい、あり
思い
がとうご
ます。
ざいます。
はい。
よろしくお願いします。
よろしくお願いします。
開発した恐怖系。
宮本さん、すいません。ちょっと共有を変えさせていただきます。
わかりました。はい。じゃあ私の共有停止すればいいですか、私が。
はい。僕はちょっと切り替えるので大丈夫です。
大丈夫ですか。はい。
はい。これで。はい。Okay, so it's now 4 p.m. So we're going to slowly start this event. Yeah, thank you very much for everybody coming today. So today's speaker is by Kentaro Miyamoto. I'm very happy to host his event. So before we move to this event, people come a little bit slowly to this room. So I usually talk about what is Consciousness Club Tokyo. Yeah, please let me talk about the what is Consciousness Club Tokyo. Right. Okay, a lot of people coming. So we are Consciousness Club Tokyo. This is kind of international online community that is to talk about anything related to consciousness studies. Could be like from mathematics, physics, medicine, neuroscience. This is kind of any related fields are welcome to have this in this community. And audience, we also would like to have people from any field and not only specialists like academicians, but also people who are interested in consciousness. And we usually have a once a month at this event, and speakers should be all over the world. Right, so today's event, sorry, like too many, where is that? Okay, so we are going to start from 4 p.m. in Japan. And so we are going to, so we already introduced the Consciousness Club Tokyo. So I like to introduce Kentaro. So sorry, like a lot of people is now waiting in the waiting. So I just okay. Right. So yeah, I'm very glad to introduce Dr. Kentaro Miyamoto, team leader in RIKEN CBS. Kentaro has started his career on memory in macaque monkey with fMRI in University of Tokyo. And then Kentaro identified metacognitive self-monitoring aspect of memory, so-called meta-memory. And he also studied underlying neural mechanism or judgment on meta-memory. So after he worked in University of Tokyo, and he moved to Oxford University, working together with Matthew Rushworth. And he worked several years, and he now became a PI in RIKEN CBS. I have been waiting for this opportunity to invite Kentaro because like he is like kind of front runner of this studying metacognition and decision making. I'm very happy to have host this event. So okay. So let's welcome Kentaro and listen to his talk. Okay. So you can start anytime. I'll stop sharing.
Okay, yeah, thank you for the introducing me, Hiroaki. If everyone is ready, okay, yeah, I will start my presentation. Okay, so, should I share my screen first? Yeah, okay, and yes. Okay. Can you see my screen?
Yes.
Can you hear me?
Perfect.
Okay.
Yes.
Okay. Okay. Thank you. Okay. Okay. So, okay. Okay. So, thank you for the nice introduction, Hiroaki. Yeah, I'm coming back from Oxford this summer, and I started my new research group at RIKEN. Our interest is some metacognition, cognition about cognition, and maybe that is popular topics in your seminar. But today, I want to show you some findings of the neural process of the metacognition that I found in some study in the Oxford and in Tokyo. Okay. So our interest is our thought of the humans and how we understand the external world. Okay. Please see this picture. This is a self-portrait that is drawn by the Escher. The Escher is a very popular artist, drawers of some masterpiece of the illusions. But yeah, in this picture, he draws his own figures, but his own body is reflected by the very iron balls, and that reflects his shape. So this self-portrait illustrates the introspection that I'm very interested. Here, the Escher see his face, and he sees he is in the room, and he is seeing himself. Okay, so in this situation, the mental state that he works is introspection. In this situation, he understands that he is watching his own face, and he is recognizing that he is in his room. Okay. So I think that introspection is that some cognitions of the self and the environment and the interaction of these. Okay. But our interest is that to investigate this metacognition, this introspection, but it is a bit difficult to investigate only in the humans because the method we can apply is limited. But we apply this paradigm to the animals like macaque monkeys, and some psychological study that shows that some animals, including monkeys, has the ability to do the introspection. So in our research, we developed some psychological paradigm to examine the introspections of the monkeys, and then we examined how the brain works by using the more fine and more invasive method. Okay. Yeah. And introspection, okay, it's related to the process that calls metacognition. Okay, so metacognition is that the cognition of the cognition, and then some mental process to understand that how the subject, the oneself, is thinking about. So in this situation, is that this monkey is thinking about his memory by saying some diary, but some metacognitive process of this monkeys is that he is understanding that he is recalling some memories. Okay, but this understanding is related to some evaluations or the monitoring of this process itself. So in some situations, this monkey is very confident about the past memory, but in some situations, he feels very uncertain about this memory. Okay? This kind of self-evaluation is metacognition, and for the introspection of the past, this metacognitive processing is quite important. Okay. And actually, the past neuroscience studies focus mainly on this introspection for the past. Okay. But in our study, okay, we focus on the features of the introspection for future decision making. Okay. In the ecological situation, okay, sometimes some subjects, like animals, humans, use this metacognitive process for the future actions, like planning to go to somewhere, so the planning for the explorations, or the planning to look for some food in the field. Okay, to make this plan, okay, this metacognition is quite important. Okay? But we call this type of metacognition as a prospective metacognition. But in the previous studies, this prospective metacognition is not examined well. Okay, so in our study, we first focus on this feature of the metacognition. Okay. So make sense so far? Okay. Okay. So to examine this prospective feature of the metacognition, okay, we at the same time we focus on the two different types of uncertainty or the probabilities. Okay. Please imagine the situation that you have to drive to a restaurant for dinner, but the car you drive has no car navigation system. Okay. In this situation, for the future dinner, okay, you need to think about the two different types of the probability. Okay. One probability is environmental probability we call, or the external probability, and this is related to whether the restaurant is open or closed when you decided to drive. Okay. Okay. This kind of the probability, yes, is it's beyond someone's control, and this is determined by the environmental situation. So that we call this as the external probability. Okay. The other probability that you need to think about in this situation it's more subjective probability. Okay? In these situations, you need to retrieve and remember the route to the restaurant because the car navigation system is not installed. Okay, so the high probability you can arrive at the restaurant is another type of the uncertainty or the probability. Okay. So our interest is that how our brains compare these two kinds of probability before the decision making, like before to decide to which restaurant you go to. Okay. And we focus on some of the brain activities during the comparison of these probabilities. We can see some brain mechanism for the metacognitive judgment for the futures. Okay. And we can also examine the brain activities during doing some task, like doing some driving, and then we can see how confident they can do the task. In this case, they can drive without car navigation. Okay. So yeah, in this study, okay, we developed a psychological paradigm to compare the two kinds of probability, okay, behavioral decision making by using some psychophysical stimulus setup. Yeah. Okay. So in our research, okay, to test the brain process to compare the internal and external probabilities, we invented some stimulus that using the moving dot. Okay. In this task, a lot of dots is presented on the screen. Okay. And they are moving in the leftward or rightward. Okay. The participant task is to judge if the majority of dot is moving in the rightward or the leftward. And basically, when they can discriminate the motion directions correctly, successfully, and then they can get the reward. But the reward they finally received is probabilistic in some situations. Okay. Okay. In this task, okay, so we introduced two different dimensions in this stimulus condition. And one dimension is coherence of the motion, and the other dimension is the number of the moving dots. And the trick of this study is that the reward that is delivered after this task is determined by the success or the failure of the discrimination of the task and the probability of the reward that is indicated by the number of the dots. Okay. So in this task, okay, so the difficulty of task, or in other case, the success or the failure of the task, and that is related to our skills and of the motion, the discrimination. Okay. Yes, it's this index is reflected by the coherence of the motion, and then this coherence of motion is correspond to the internal probability that I explained. Okay. And in the task, the number of dots, okay, and it indicates the probability of reward that is received after the participant can classify the motion directions correctly. So the number of dots is some uncertainty, but that is not controllable by the people. and that is given by the environment. So this number of the moving dots correspond to the external probability. Okay. So in the tasks, basically, we presented the two different type of the motion, the coherent moving the dots. And in one moving dot options, only the coherence motion is changed across the trials. And the other option, only the number of dots or the external probability is manipulated. Okay. And we give the two different type of the options on the screen to the participant, and then the participant are asked to compare these two different type of the probability, and then choose better options that will give them the reward with a higher probability. Okay. So by using this paradigm, okay, we can see some of the brain process to compare this internal and external probability before the decision making. So in the example of the driving to restaurant for dinner without qualification, then this environment probability is correspond to the number of the moving dots in this task. And the subjective probability, okay, so whether you can reach a restaurant or not, this internal probability is correspond to the coherence motions in this task. Okay. So is everything clear so far? Okay. So, okay, this is the schedule of the task. Okay. In the task, okay, the two options. The one option is only the internal probability is manipulated, and the other option, only the external probability is manipulated, is presented on the screen first, and then the participant is asked to choose which tasks that they want to perform. Okay. Okay. This is a very important point, and I want to repeat this. Okay. In this task, okay, so the internal option is that it contains the full of the dots. Okay, so that it means that the external probability of this internal option is always 100%. So in this task option, if the participant choose, if the participant classifies the motion direction correctly, and then they can get the reward for all trials. Okay. This external option, okay, this external option is that all dot is moving in the same direction. Okay, so it means that there is no internal uncertainty. Okay, so the internal uncertainty is nothing. So the participants never fail to discriminate this motion, but the reward that is given is determined by the number of dots. So the reward is probabilistic, and then this reward is given by the number of dots. Okay, so the participant's task is to guess how well that they can perform this internal task in this situation, and they estimate the probability that they can get reward, and then they compare the probability of reward that is given by the external probability option, and then they choose the better option that they should try. Okay. After that, they pick up the one task option, and then the chosen task is repeated in the second stage. Okay. And in the second stage, the dot is moving in the leftward, rightward, and then the participants are asked to judge if the majority of dot is moving in the rightward, leftward. And then the outcome, the feedback is given here, and the outcome or the correct or incorrect this task is determined by the actual their response toward this task, and then the number of dots that is contained in the stimulus they chose. Okay. So this is we use okay. So and in this task, another trick is that motion direction of the dot is different in this first stage and second stage. In the first stage, all dot is moving is upward and downward, but in the second stage, the dot is moving in the left or rightward, and then so the direction of the dot moving is different, but the stimulus presented here in the first stage and second stage is exactly the same, and just rotated in the 90 degrees or the minus 90 degrees. So by using these tricks, okay, so we can prevent participant from making some decisions of the motion directions in the first stage, and we can associate this the first stage and second stage. So the second stage, the task is exactly the same in the first stage, and then they can prospect their performance in the first stage, and then they use some of the metacognitive process to choose task that they want to try. Okay. Is everything clear for now? Okay. Good. Okay. First, we want to focus on some behavior during this metacognitive judgment stage. Okay. Okay. So in this task, okay, so the internal probability options and external probability options is manipulated from the lower probability to the higher probability, okay, lower probability to the higher probability, okay, and we can see the preference to choose this internal probability options toward the internal probability here, okay. And the result is like that. Okay. Okay, so here in the x-axis of this figure, it shows internal probability and actual internal probability, and this actual internal probability is correspond to the actual performance to classify the motion directions of this ambiguous motion. Okay. As you can see that from left side, all dot is moving in the very random directions, and it's very difficult to discriminate the motion direction. But in this right side, the all dot, most of dot is moving in the same directions, and it's very easy to discriminate the motion. Okay, so that we use a different coherence level, so different randomness of the dot motion level for this task. But before this task, okay, we can examine how well the participant can do that, and as a baseline the performance, and then we can convert its coherence of its coherence condition towards the actual performance. Okay. So that this actual performance is plotted on the this x-axis. Okay. And y-axis here, it shows that proportions of trials that the participant actually chose the internal option preference. Okay. So it shows that some proportions of trials that the participant choose this internal option in this task. Okay. As clearly shown here, okay, so the proportion of trials that the internal option is chosen is systematically increase as a function of the internal probability. So it means that the participant, okay, can estimate this internal probability, and then they can change the selections of the task, internal task, during this metacognition task. Okay. In the right side, we show that the functions of the external probability that is shown by the stimulus, and the proportions of the trials that actually the participant chose external option. Okay. As shown here, this preference is systematically increased as a function of the external probability. So the participant can use this external probability information and then change the metacognitive judgment here. But actually, okay, in this task, we presented all combinations of the internal probability and external probability. Okay. So like that. Okay. So if the participant perform this task in the very optimal way, okay, the participant should choose this external task when the external probability is high or the internal probability is low, that I'm here. But if the internal probability is high and the dots is moving in the same directions, or the external probability is low, the dots contained in the external probability option is small, then the participant should choose the internal task option. Okay. So this is the behavior that is expected. And actually the performance is like that. Okay. And human participant, okay, can perform this task in the very optimal way. Okay. And this black trace shows that the baseline performance of the each internal probability option. Okay. Okay. As you can see here, around here, okay, the task preference, okay, is changed across this border. Okay, so in the below of this line, okay, down here, the participant clearly choose this internal option more, and above this line, that they chose external probabilities more. Okay, and this is consistent with our expectation and our prediction. And another interesting thing is that their preference, task preference, is a bit biased towards the internal probability. Okay, the line of the 50% is slightly below the line of the actual performance. Okay, so it may reflect that some difference of the estimation, the process of the subjective internal probability and external probability. Okay. Okay. So in the here we quantified, okay, the effect of the internal probability and external probability on the selection of this task. Okay, in this analysis, okay, so this regression analysis estimate the proportion of the trials that participant that chose internal option, internal task, by using the two regressors, the two effects. The one effect is internal probability and external probability. Okay, as shown here, okay, the effect of the internal probability is positive. That means that if the internal probability of the motion coherence is high, then the participants tend to choose the internal tasks more often. Okay, but the effect of the external probability is a negative. That it means that if the external probability is high, the participants tend not to choose the internal task and rather to choose the external task. Okay, these two contrastive effects confirm that the participants, okay, change their task selections based on both internal task option, internal probability, and external probability. Okay. Okay. And next, we evaluated to classify some of the trials in the below this line. So some of the trials that the internal option selection is optimal, and the trials that is above this line, the trials that the external probability option is optimal to choose. Okay. Okay. So in this index, it shows that, okay,
this index is type 2, the AROC is the index of the metacognition, and then this index close to 1, if they perfectly classify the internal optimal options as internal task selection and external optimal task conditions to the external task selection. Okay, and if they choose, okay, this internal task and in the random way in these each stimulus conditions, that this index is around 0.5. Okay. And see here, okay, this type 2 AROC index is higher than this chance. So it means that most of the participants has a good skill to classify these two types of trials based on their actual performance. Okay. And this index, the type 1, the AROC index, it shows that the baseline performance of the motion direction, the discrimination towards this either the motion coherence condition. Okay, this index is higher than the chance. It means that the all participants can do this motion task in a reliable way. Okay. Make sense so far? Okay. Okay. And the also the focus on the performance of the second perception decision stage. Okay, in the this perception decision stage, okay, some trials the participant choose the internal task, and some trials the participant choose the external task. Okay, when they choose the internal task, okay, the performance is functions of the coherence, okay, or the internal probability. Okay, that is very natural, and then yeah, that is good. And for the external task option, their performance or the probability of they get rewards is a function of the external probability. Okay, well, that is natural and that's good. But the interesting observation is that the effect of the external probability on the internal task performance here. Okay, so that this external probability is related to the external probability in the first stage, and this option is not available during this second stage. But this probability is affect on the internal task performance. Okay, so that we consider the effect that it comes from the task selection here. Okay, in the first stage, if the external probability is very high, the motivation to choose the external probability is very high for the participant. Okay, so that in the situation that the external probability high, the participants rarely choose the internal task option. But in some situations, the participant is super confident about the internal task, even when the external task option probability is very high. In these situations, they intended to choose the internal option then. So the performance of this task is very high. So we think that this external probabilities affect on the internal performance in the second perceptual decision stage. Okay. Okay. Make sense? Okay. Okay. So first, we want to focus on the neural activity that is collected in the MRI experiment. Okay. We want to focus on the perceptual decision stage first. Okay. Okay. So please remember the example of the driving to the restaurant for dinner with the sky navigation here, and we are interested in the external and internal probability. Okay. In this analysis, okay, we want to focus on the some common neural substrate for the both external and internal probability during this second perceptual decision stage. Okay. As seen here, the brain regions, including some prefrontal region and posterior parietal region, is commonly active in correlation with the internal and external probability here. Okay, so the one area is inferior parietal lobule, and this area is known to related to the visual motion, the processing systems. Okay, and another interesting area is area 8A, and that is a homologue of the monkey frontal eye field, and that is very important for the visual motor processing too. Okay. So these two brain areas is commonly active towards internal and probability, internal and external probability here. Okay. And another interesting brain site is ventromedial prefrontal cortex. Okay, so this ventromedial prefrontal cortex is known to encode some value of the options, and that reflects some probability of the rewards that the participant can get. Okay, this ventromedial prefrontal cortex is active in response to the internal probability and external probability there here. Okay, and this trace shows that some effects is correlated to the chosen internal probability, chosen internal probability and chosen external probability. Okay, this area is response to the option they actually choose, but this same area is not active towards declined options in the previous stage. Okay, like that. Okay, so that is consistent with the previous works on the features of the ventromedial prefrontal cortex. Okay. Next, we want to focus on some neural substrate that is specific for the internal probability here. Okay. The results are here, and we found that the front polar cortex, the medial part of the front polar cortex, is active only in response to the internal probability, but it is not active towards the external probability. So we consider that we think that this brain region is important for some monitoring of the internal probability during the decision making. Okay, makes sense so far? Okay. Okay, so the next we want to move to the brain mechanism of the metacognitive judgment in the first stage. Okay. And in this analysis, we focus on some brain mechanisms that are related to the internal probability here, because we find that only the substrate for the internal probability during this metacognitive judgment stage. Okay, shown in this slide. Okay, the anterolateral prefrontal cortex, where is the anterior lateral side of the this prefrontal cortex, is active towards internal probability during the first prospective metacognitive judgment stage. But interesting thing is that this anterolateral prefrontal cortex is active to both chosen internal probability and unchosen internal probability. Okay, in this task, okay, the participant have to choose the internal task option or the external task option in the first metacognitive judgment stage. But in some case, okay, the participant choose the internal probability option and they do this task. But in other trials, the participant choose the external task and then they rejected the internal task option. But this area, anterolateral prefrontal cortex, is encoding this rejected the internal probability option here. So this is one of the interesting point. Okay, and second interesting point is that both chosen internal probability and unchosen internal probability is related to the activity of the anterior prefrontal cortex, but the slope, the speed of the accumulating of the effect is different between the chosen and unchosen, the rejected internal probability. Okay, for the chosen internal probability, the effect is increasing is more quickly, and the slope is very steep. Okay, but for unchosen internal probability, okay, the accumulations of the effect is very slow, and the slope is less steep. Okay, and this slope is different across the subject. Okay, but during the perceptual decision stage, okay, the anterior prefrontal cortex is active towards both the chosen and unchosen internal probability. Okay, but there is no effect of the slope or the accumulation of these signals. Okay, these results, okay, demonstrate that this anterolateral prefrontal cortex is contribute to the subjective evaluation of the internal probability. Okay, and our hypothesis is that the participant, okay, and has a very confident to perform this internal probability task, and then some accumulations or evidence for the internal probability is high, and then finally they choose this internal probability option. And if this evidence accumulation is very slow and they're less confident, and then they finally reject the to choose the internal probability option. So we hypothesize that the anterolateral prefrontal cortex is some of the estimator of the internal probability during the prospective metacognition judgment. Okay, make sense? Okay, and we also examine the effect of this evidence, internal evidence accumulations and activity of the internal probability across the participant. Okay, as shown in this top row. Okay, anterolateral the prefrontal cortex activity. Okay, that is evaluated by the difference in the slope of the towards the chosen internal option and unchosen internal option. Okay, is correlated with metacognitive judgment performance across subjects. Okay, here this performance index and then the difference between the slope is correlated. Okay, but yeah, but this is not significant for the frontal cortex. Okay. But in contrast, for the frontal cortex here, is that is coding the internal probability during the second perceptual decision making stage, and this activity is correlated with performance of the perceptual decision task here. Okay. Okay, so this contrasted the features of the anterolateral prefrontal cortex and frontal cortex. Okay, okay, shows that this anterolateral prefrontal cortex is important for some of the evaluations on the internal probability during the metacognition, and then the frontal cortex is important for to perform the internal task or to estimate some of the confidence of the internal tasks during the decision making. Okay. Okay. Finally, okay, we examined some of the causal effects of the anterolateral prefrontal cortex disruption by applying the TMS stimulation, the transcranial magnetic stimulation. Okay, So by applying this TMS, we can silence some of the brain regions activity for a few hours, okay, without any invasiveness effect. Okay. Okay. So we applied this TMS to the anterolateral prefrontal cortex, and then we examined how their metacognitive task preference changed. Okay. Okay. So this figure here shows baseline performance, okay, of this metacognitive selection task here. Okay. As shown in the figure, and then the participant performance is consistent with the MRI experiment, the previous experiment. Okay, and when we applied this TMS to this brain site, okay, the activity, the preference to the internal tasks is slightly changed, and actually some the boundary of the to choose the internal and the external option is a bit shifted, and some patterns around here is a bit different. Okay. So this right here shows some of the difference of this anterolateral prefrontal stimulation condition and no stimulation condition, and then that you can see that around this boundary, based on the baseline for task performance, okay, the task selection, the preference of the task selection changed dramatically. Okay. So finally, okay, we evaluated the performance index after the anterolateral prefrontal stimulation and the control stimulation. Okay, I think here some of the basic perceptual decision making performance did not change by the stimulation of the anterolateral prefrontal cortex and control the stimulation. And for the metacognition, the performance index, for the control conditions, there is no difference between the stimulation and the no stimulation. But for the anterolateral prefrontal cortex stimulation, after the stimulation, the metacognitive performance is impaired as compared with the no stimulation conditions. Okay, so these results shows that anterolateral prefrontal cortex is crucial for the prospective metacognition in the first stage, but it is not for the perceptual decision making itself. Okay, so in this study, we found that anterolateral prefrontal cortex is a specific site to accumulate evidence of the internal probability for the prospective metacognitive judgment. Okay. Second, okay, we want to show our different study that we examine the neural process of the metacognition for path. Okay, as I explained in the slide beginning. Okay, so the metacognition is very important for the thinking about the past decision. Okay, to test for this past metacognition, we designed some the retrospective metacognition task for the macaque monkeys. Okay, in the task is consists of the two stages. Okay, in the first stages, the monkey memorizes 4 pictures that is serially presented on the screen, and then their task is to judge if this choice option is included in the encoded item list before this retrieval phase. Okay. And after this mnemonic, the memory decisions, okay, the monkeys cannot get any reward, but instead of that, they are given another stage that asks the monkey to have some gamble of the high bet or low bet option. Okay. In this second bet stage, okay, if they choose the high bet option, okay, if the monkey's performance is correct in the previous memory stage, that they can get plenty of reward. But if they fail in the previous memory stage, they cannot get any reward, and then they give the long timeout as a penalty. Okay? And if the monkey chose this low bet option, okay, the monkey can get a small amount of reward, irrespective of their performance in the memory stage. Okay, so that by using this paradigm, okay, so if the monkey choose the high bet option, if they think that they success in the previous stage, okay, but if the monkey thinks that they are not confident and they are uncertain if they can give the correct answer in the memory stage, the monkey should choose the low bet option. Okay? By using this strategy, that they can maximize the reward they can finally get. And actually, the monkeys performed this task in the very optimal way. So that is, if the monkey thinks that monkey give the correct answer here, the monkey choose the high bet option more. And if monkey thinks that they are failed in the previous stage, and then they choose low bet option more. Okay. And in this fMRI study, okay, we look for some brain regions that reflect this metacognitive performance. Okay, and as seen here, okay, so that we basically examine some of the correlations of each brain region with the metacognitive performance here. And interestingly, this front polar cortex is focally correlated with the metacognitive performance of the novel items judgment. So in this task, actually, half of the trials, monkeys recognize that this picture is not included in the encoded picture list. Okay, in this situation, the monkey do some of the novelty judgment. Okay, and in the bed stage, after that, in the bed stage, they think about their novelty judgment. Okay. In this metacognitive process of the novelty judgment, it's this condition, and front polar cortex is a specific locus for this self-evaluation of the novel item judgment. Okay, but in contrast towards metacognitive judgment of the memorized items, okay, there's no site. Okay, that is correlated with the metacognitive performance, especially in the front polar cortex. And instead, those lateral prefrontal cortex, called area 9, is correlated with metacognitive performance of the memorized items. Okay, so we apply some of the MUS models. So that is a GABA A receptor agonist, and that silencing the neuronal firings for the several hours. Okay, we applied this MUS model to the front polar cortex or the dorsolateral cortex, and then we examine the metacognitive tasks, the performance index change. Okay, as expected, for the novel items, okay, for the memorized items, this metacognitive judgment performance is not changed, not different across the MUS model injection condition and controls the saline injection conditions. Okay, but towards the novel items, okay, this metacognitive performance index is impaired, okay, as compared to the saline condition. But for the dorsal prefrontal injection, okay, the metacognitive performance index is impaired towards memorized items as compared in the MUS model injection conditions as compared to the saline injection conditions. But towards the novel items, there is no difference in the impairment across Mushimura and saline conditions. Okay, so the studies shows that from the polar cortex and then those lateral prefrontal cortex is important for the metacognitive judgment of the novelty and metacognitive judgment of the memory. And this okay. So okay. So in this in our study, okay, in the first human study, okay, we found that the front polar cortex, area 10, is important for the evaluation of the current consciousness. So that is related to the activity of the during the second perceptual decision stage in the human experiment. Okay, and in the macaque monkey experiment, okay, area 9 is important for the confident judgment of the memory, and area 10, the frontopolar cortex, is important for the confident judgment of the novelty. Okay, so this area 10 and 9 is important for the metacognition for past or the present. But for the future metacognition, we found that the lateral prefrontal cortex is critical. So in our studies, for the first time, shows that the critical locus for the past metacognition and future metacognition is separated and independent. Okay, and another interesting thing for me is that the evolutionary origin of this neural substrate of prospective metacognition. Okay, in the human study, we found that this anterolateral prefrontal cortex, area 47, is important for the prospective metacognition. But this brain region is evolutionary novel, and there is no functional counterpart is found in the macaque monkeys. Okay. In the studies from the Rushworth lab, this study is to examine the functional counterpart of the one brain regions, okay, based on the functional connectivity patterns across the other brain regions, okay, like that. Okay, so in this study, they compared some the pattern of the functional connectivity from the one human brain region, and then they compare the monkey's regions, and then they compare the similarity of the functional connectivity pattern, and then they determine the which monkey brain region is correspond to the which human brain region. Okay, by using this method, most of the monkey's brain regions can be assigned to the human brain regions, but this area 47, the anterolateral prefrontal cortex, has no functional counterpart in the macaque monkeys. Okay. But in our ongoing project, okay, we found that macaque monkeys perform this task in a very similar way to the humans. So now we conducting the functional MRI experiment in the monkeys, and then we are looking for some brain site that is corresponding to the area 47, the lateral prefrontal cortex, that is missing based on the comparisons of the functional connectivity network. So this is the collaborators of our studies in the human studies in the Oxford and the monkey studies in Tokyo. Okay, and we started I started my own lab from this July at RIKEN CBS, and our interest is future imagination, social cognition, curiosity, and metacognition in primates. And we use these methods like the functional connectivity, functional MRI, electrophysiology, and optogenetic, and we want to show the neural mechanism of these highly cognitive functions. And together with this method, Okay, we use a comparative neuroscience method, and we use a functional MRI, and we want to compare the brain mechanism of the humans and macaque monkeys. Okay, based on these two different approach, we want to reveal how our future imagination or the social cognition is generated from our neural circuit. Okay, if you are interested in our research, or if you want to join in our office, please contact with me by sending me email. Okay, so thank you very much for paying attention to my talk.
Right. Yeah. Thanks a lot for the great talk on future and past neural mechanism of metacognitive approaches. Yeah. So sorry. Yeah. I already use count now. Sorry. So we had already like a little bit long talk. So why don't we have a small break? So now like 5:03 p.m. So let's come back like 5. Yeah. Yeah. 5. Yeah, let's take a like 3 minutes break, like 5 6. So yeah, we're going to start very slowly. So if you want to ask question, you can also put the question on the chat. Yeah, so yeah, let's have a short break. Okay, already 5 6. So yeah, let's start the discussion session. And we got already like question from sorry, I can't pronounce Mamet. If you already here, like, can you ask maybe like extra questions, or are you here?
Okay, hello, I am here.
Yeah, yeah, sure, please.
I was just walking. So I was, I could not understand all the details of the task, and I'm just wondering, when you associate memory confidence with area 9, is it involved in determining the memory confidence, or does it have the outcome of the memory confidence, or does it have some kind of both the outcome of the memory confidence, but some kind of a motor preparation signal to response based on the memory confidence? You know, it could have various different functions of memory confidence as an output.
Thank you for the nice question. And that's a really good question. And this monkey study, we focus on some of the brain activity during the memory retrieval. Okay, so during the memory retrieval, when they judge if the target picture is included in the encoded memory list or not, and we extract some of the brain signals there, and then we see some of the correlations of the signals, okay, during this memory retrieval. Okay, so we think that this signals is related to some of the confidence that is read out during the memory retrieval. And we think that based on this read out confidence signals, some of the monkeys is started some of the process to choose the better options in the later stage. Okay, so in this presentation, I didn't show this result, but in another study, we now investigating some of the brain activity during this BET stage, the post-decision measuring. And this post-decision measuring, we found that the posterior parietal cortex is very important for this metacognitive judgment. And more importantly, this posterior parietal cortex is important for both metacognitive judgment of the memory and metacognitive judgment of the novelty. So we hypothesize that some read out the confidence signals that is task specific during the memory retrieval is processed after this memory retrieval to the post-decision measuring, and then at the stage of the post-decision measuring, okay, these signals is converged, and then that is monitored in the posterior parietal cortex, and then the posterior parietal cortex is contribute to choose the high bet or the low bet option during the bet decision stage.
Thank you very much.
Thank you.
Yeah, thanks a lot. Any other questions? Anytime questions. You know, let me ask maybe a little bit the trivia question, but you show that neural correlates of internal and the common neural correlates of internal and external probability. But have you also checked the specific to external probability?
Yeah, that's very, very good question. And I try to see the fit brain areas is active towards external probability, but actually we did not find any of the brain regions that is specific for the external probability. So some maybe so the external probability, the option area is some subset of the internal probability region. So that is interesting in the second perceptual decision stage. Okay, but in the first metacognitive judgment stage, okay, some parietal cortex is in response to the external probability, but the effect is inverted. So the negative effect towards the chosen external probability is there. Okay, so we hypothesize that maybe some of the interactions of the anterolateral prefrontal cortex and posterior parietal cortex is key for the metacognitive matching of the internal probability and external probability during the first stage. Okay.
Yeah. Thanks a lot for the answers. I was kind of curious about it. So, right, and yes, and also we got a questions from Asako. So on the chat, like if you are available, can you directly ask Asako-san?
Thank you very much for the exciting talk. I just asked the internal and external risk preference that affect the choice in the first human experiment. In the discussion, there is no explanation of the risk preference, and the assumption is just human prefer the maximum the reward is the choice in the choice, but in more in real choice is more complicated, and the location of the alPFC in your data is the anterior part of the alPFC.
That's another good point. Actually, my the location of our spot is a bit anterior compared to the anterior alPFC. Maybe that's because you are thinking about some brain regions of the task switching, or like inhibitions of the some actions or like that in the anterior. The alPFC is very important. And then, this area is examined, many times in the previous study. But our spot is a bit anterior towards this place, and then the very border of the area 47 and area 45. Okay, so this is a very new place, new spot that is reported before, and maybe some few studies, like from the John O'Doherty lab, and then in his study, and that he finds that some this alPFC regions is important for the maybe the model-free learning. So that we label these regions as alPFCs rather than the alPFC.
The location of alPFC more posterior part is related with risk preference.
Risk preference, I think so. But in this study, we didn't identify any activities that is related to the site. But but during the perceptual region stage, some activity is a bit spread from this alPFC. So some activities in some cluster of the prefrontal cortex may reflect some risk evaluations, but in the first prospective metacognition stage, there is no signals that are correlated with risk.
First metacognitive.
First task selection stage, there is no signals that are correlated with alPFC that you are interested. But in the second, just a decision making stage, so that just doing some internal task, and then some brain activity is spilled out from the alPFC, and then some activities that we captured is reflecting some risk assessment factor, I think.
So I can understand the location and the explanation, but in the choice itself, how to the internal risk preference and the external risk preference is related to the choice. So how do you think the designers are these two kind of the risk preference and the internal probability and the external probability and the confidence, the relationship is a little bit complicated, and I can understand easily to understand in your design. could you explain the relationship, the preference, the internal external preference and the choice?
Actually, in our focus is on the first prospective metacognition stage. In the first prospective metacognition stage, the participant clearly use their metacognition because they expect the internal task performance in the future, and then they have to compare it with the external probability, right? In this prospective metacognition stage, okay, only the anterior lateral prefrontal cortex is active, and no prefrontal cortex area is not active towards this process. So there's no activation in the alPFC. So the thing that in this first stage is that some brain regions that is very known for the risk assessment is not included in the some clusters of the prefrontal cortex we find. So that in this study that we exclude the effect of the risk. Actually, we compared the expected reward rate of the internal option and the external option. But this expected reward value is the same. There is no significant difference. And some variance of this reward probability is also the same across the internal and external options. So that we think that there is no difference between internal and external here. So that there is no effect of the risk. It's identified in the first prospective metacognition stage. Okay? And in the second, the perceptual decision stage, their task is to judge if the motion direction only for the motion directions, and there is no explicit task to judge some of the confidence or some risk. But some brain regions that track some of the risk or confidence, and then some of the brain activity that captures the risk or the confidence is shown in the results. So I think that this perceptual decision stage, the result is the mixtures of some results, some effects, and it's good to dissociate some effects with more as final tuned some tasks if we are interested.
Thank you very much for the explanation. Thank you very much.
Yeah, great. So we still have time, so please, if anybody has questions. You can also use like the action button and then raise your hand or something. If not, I also have another question. Yeah, I was wondering. So in the second part, like a little bit last part, so it's about a meta memory. You talked about for the memorized trials that those alPFCs can activate it. I was wondering. So I thought maybe meta memories kind of reflect also like some what actually they memorize. So the memory related region might be activated. And have you? So maybe hippocampal complex also activated, but maybe in the failure trials, I don't know. Have you checked the failure and like a success trial? Those are also activated, or like some differences between two different trials or something. Sorry, it's a little bit.
That's a very good point. And actually, in the very old project, before we moved to this meta memory project, we focus on just on the first part of the memory task, and then we see some brain activity during the retrieval and encoding. And actually, during the encoding, we found that the hippocampal activity predicts the performance in the retrieval. So in the trials of the correct memory trials and the miss trials, the failure in the memory trials, the activity in the hippocampus is very different. And then we also find that some entorhinal area and the peririnal area is also the signal associated for the success of the encoding and the failure of encoding. Okay, and in this study, we found that strong functional connectivity between the hippocampus and the frontal cortex, and hippocampus and dorsal area 9. So, and we also find that strong functional connectivity between the frontal cortex and the dorsal prefrontal cortex, area 9 and 10. So that maybe this network is very crucial for to send some of the signals of the memory towards the frontal cortex, and then they use this information for the metacognitive judgment of some novelty. So that maybe the novelty judgment itself is a bit metacognitive, a bit higher process, because they have to understand the absence of the memory. And in this task is a bit crazy thing is that they have to think about self-evaluations of the absence of memory. So the frontal cortex is a very specific side of this metacognitive process of the absence of memory. And maybe it's I think that it is a very interesting point is that. And then but to achieve this very, very higher process, we think that some of the information that is processed in the hippocampus or that is processed in the area 9 for the metacognition of the memory has a critical role. So that we are very interested in some of the interactions of the area 10, area 9, and the hippocampus. And we want to see some signal flows by the electrophysiology in the future in my group. Yeah. Sorry, maybe the mic is muted, so you say something. Okay.
Can you hear me?
Yeah. No, okay, yeah.
Okay,
yeah,
okay.
Yeah.
So how much did I tell you? Okay, maybe like I should start from another question. Yeah. Thank you so much for great answers. Yeah, it's quite interested in how you work on that. And another point I was interested in is you in the collecting data from monkeys is a bit hard, but in the first experiment you did with humans, and you showed that the choice toward internal probability is much higher than the external probability. I was wondering the maybe there's some part of the connectivity between like a BMPFC or a front polar region might determine the bias of the individual selections or something like that. Do you have any thought like how bias, individual bias toward internal probability.
Yeah, that's another good point. And then, yeah, so in the metacognition studies, to dissociate the effect of the metacognitive efficacy, some of the ability to the metacognitive judgment, so like the ability to classify trials, so the high confidence or low confidence, or to choose the task optimally, and some of the biases, so their preference to the high bet, or the internal, and then it's very good to, it's very critical thing to the dissociate the two. And in my second experiment, in the monkeys experiment, we find that the front polar cortex activities are correlated with metacognitive efficiency. So like a metacognitive performance, so the classifying some of the trials rather than the bias itself. Okay, so we inactivate this front polar cortex. Okay, so their metacognitive performance is impaired, and then their assignment of the high bet and low bet towards the correct or the incorrect trials is collapsed. But their preference towards a high bet or low bet did not change. So the ratio to choose the high bet or low bet is not changed. So we think that the front polar cortex is not important for some bias, but rather for the more metacognitive process itself. So I think that some connectivity between the front polar cortex and VMPFC, that is not for the bias, okay? But maybe, VMPFC itself may be related to some value activity itself. So maybe we can, show that some the effect related to the bias in somewhere with the VMPFC. And another possibility is that alPFC. The alPFC is very sensitive towards the strength of the subjective evaluations of internal probability. Okay, so in the same stimulus condition, but there's the accumulation of the evidence is very quick, and finally the participant choose the internal task. If this is slow and very steep, and they finally choose the external task. But this decision is based on the accumulation, the speed of the alPFC. So maybe some very liberal people is they decided to choose the internal options by just very small accumulations of the internal evidence. Okay, the participant may choose the internal probability options more. Okay, so maybe the alPFC is a very key area with interaction with some other areas to determine some of the bias across subject.
Yeah. Oh, yeah. Thanks a lot for the answers. So thanks a lot. And please, if anybody had questions, you can also have a comment on the talk. We still like this is like just how do you say, more, we try to make this discussion in a more relaxed way. So
any questions? Okay, so outside of this study or
so you came back to Japan like this summer, like around July or
July is officially started the lab, but I started preparation from May. So and now it's very tricky the situation, and we need to self-isolate for 2 weeks.
I see.
And then and set up the labs,
experiments.
The lab is for the monkey physiology, so we are now starting to make some setup for the monkey experiment. So it's
I see. And this is just a very naive question. And I have no experience with monkey fMRI. So do you also what kind of habituation training do they need? Or
we need maybe extensive, long training with the monkeys.
I see. But you don't use any like a drug to how do they constrain their bodies or How?
Constraint bodies. Yeah. Actually, that's very good point. And then, monkeys is licking some juice or some moving their hand or their body, and it's a cause of the artifact. So in the Tokyo's experiment, monkeys is trained to be very still.
Okay.
In the scanner, and then the monkey have to put their hand and foot on the sensor box to start the task. Okay. So by using this, they cannot rotate their body. So we can get good quality of the signals. So to improve the quality of data, we get to the constrain the monkeys behavior. So that's a very long process.
Yeah, because I have done mouse fMRI before. So what case like we didn't do any experiment, just we combine epigenetics but even like illumination itself can be can cause their movement because they are quite in a very dark room. They quite sensitive to illumination. So just I was wondering that how is that possible? Yes.
Monkey is well habituated, sometimes over habituated, and the monkey started to sleep in the scanner.
Okay.
That's another problem. Okay, take a nap. Okay.
Okay. I see. Okay. So it's good to know.
And sometimes the monkeys hesitated to do any task in the scanner. So that we unexpectedly collects resting state data.
I see. No behaviors is the thing. Thanks. And any other questions from anybody? Let me think. I wanted to ask a lot of questions related to also, your work. You put it a curiosity in the very last slide. And I'm also working on curiosity studies. And that work. My case is we are let the human to track so kind of let them do different tasks, and they can human can choose one of those tasks. Like we presented 4 tasks, and then they choose, and based on their accuracy of the task and maybe how much the accuracy is changed. So we call that is learning progress, and how human subjects choose different tasks in their order. Like how can I say? Maybe some people like to stick to the task with higher accuracy, but some people like maybe they like a more up and down task. Like they have a. So we try to use this kind of tasks to see their individual differences and where is a region to track this learning progress, this kind of stuff.
Is it a MRI study? So you want to localize it? So what is your target site?
Actually I'm thinking of so this learning progress. So one thing is like anterior insular cortex. So because task. So for the how can I say? So task uncertainty informations are usually seemingly tracked in the anterior insula, and the curiosity and like how kind of metacognition of how much they are improving, seemingly related, maybe related to this anterior insula. So that's why we are thinking that region might be correlated with this this learning progress. So
so that's very exciting project, I think. And frontal cortex
yeah, I want you to focus on the frontal cortex, even in your project. And the region of the frontal cortex is the effect on the learning of the new rule or the new task. That is another study from another Oxford lab, the macaque lab.
I see.
And then I think that, and then another the electrophysiology study from Stephen Wise and Tsujimoto-san. And they are recording from the anterior frontal cortex. And frontal cortex neuron is almost silent during task, but during the ITI, there is firing, and there are some self-reflection or the post-evaluation of some actions or the preparation for the new actions. So this is very related to the curiosity thing. Another point is that in our task, in our monkey task, is that we use pictures. The monkeys is familiarize, but they have to detect some of the novelty in this context. So that this novelty judgment is a very more the level of the reasoning or the cognition like that. And maybe this is a bit different from some novelty detection based on the curiosity or some surprise towards a very new stimulus or the very new environment or the very new situation. So maybe for this curiosity, anterior insurers should be the very one important site. I don't know, but or the hippocampus is also important. And maybe it's very interesting to compare these two different types of the novelty. The one type of novelty is just based on the reasoning or cognition. The other novelty is that more the bottom up and then more surprise and signals like that. Maybe that is related to your study and my study.
I see. Thanks a lot for mentioning this front cortex because so I mentioned so we are tracking accuracy and learning progress, and actually for the accuracy part, seemingly front polar cortex are seemingly tracking, but we have a very preliminary result, so not for sure, but so. I guess maybe those are so that's kind of quite how those are the work for this curiosity. I think it's my target as well, so I am very happy to hear your opinions. So that's one. And sorry, I talk a lot. So does anyone have any other comments or questions? I can also add questions. Right. So do you also have some questions to ask, or consciousness Tokyo, or like anything is fine. So we usually once a month do this event. And have you ever listen any talks? No.
No. So but I do like to visit your place and then discuss with many people in person.
That'd be great actually. So we work here, like I do more neuroscience studies, but some people work on more machine learning stuff. So and I think from more algorithmic perspective, we are quite interested in your work as well. And then
my interest is that maybe your place, like earlier, central the place of the moonshot project. So I'm curious. Oh, should I say something?
Right.
I get some question from Met. I'd imagine a rodent can also make a confident decision without area 10. Any thought on this? That's a nice question. Okay. And in my second monkey studies, I show that the area 10 is important for the confidence judgment here. But another thing I want to emphasize is that this area 10 is only for the confidence for the novelty. Okay, so just the confidence for the memory, only the dorsal lateral, the area 9 is intact. The monkey can do that. Okay, so the one answer to this question is that maybe the rodent can do the most of the confidence judgment for some of the perceptions or the memory. But yeah, and if we use some of the task paradigms, just investigate some of the memory like that. So like using some of the 2 AFC tasks or the delayed matching sample task or like that. 2 cues is there, 2 targets is there, and then choose one thing, then like that, and then only the based on the memory. Maybe that they can do this task for the rodent. But if they use like the design like us, like that yes/no design, like that the rodent can report that this is all memorized or the novel new. I don't know if they can do this kind of task itself. Okay, first, but if they can do this task, I don't know if the rodent can do that without area 10, especially for the confidence judgment for if they choose novelty options or the absence of the memory option like that. Yeah.
Yeah, thanks.
Yeah.
Yeah. Right. Yeah. Regarding Moonshot project, we are Shuntaro, last speaker, he is working on the marmoset studies. So I think maybe like working together with some people in RIKEN. So yeah, maybe it's at some point we can also discuss that that point as well. Yeah.
So I'm curious about that. How the Moonshot project people is try to use some of the findings or some of the knowledge of this neuroscience, especially for some of the metacognitive decision making or some of the confidence or the uncertainty monitoring. And then I'm interested in how some of the algorithm or I remember that you make some of the avatars, so in place of the human subjects like that. So that to make some of these avatars of some algorithms, I'm curious how well you think about this human cognition, the system. So do you have anything, any opinion about that?
Yeah, so that we have a very ambitious kind of goals to work on. But yeah, so that this how to integrate this more result of metacognition and curiosity in this more more AI systems, or like how you say, to track the intention of people to utilize the information for BMI. Actually I myself don't follow much what other people's are working on, but at least my work. So I would like to utilize my knowledge and or result to combine to somehow give insight to neural networks to work on metacognition, because we don't know how to utilize metacognition in neural networks well. So that's why I also quite kind of interested in how how your works might be related to or projects. So that's why like I was like ask you to have talks. Yeah. So yeah, I think at some point you can join some of the groups if other people's fine. I think maybe Shintaro's group would be good for to talk with, I guess. If you're interested, I'll talk with Shun and
please connect us and have another seminar for the more animals experiment oriented. Maybe it's good.
That'd be great. Thanks.
Thank you.
Right. So that'd be good because we sorry that I talk a lot to the stuff, different stuff, but we are so I have been doing it my mouse fMRI, and we are also thinking to this data to see the incorporate with some computational modeling to see the differences between like human and like marmoset and the mouse, how the brain connectivities are different and like their dynamics are different. Maybe I can't say this one, but so in that perspective, your works with like monkeys can be like a very good like macaque monkey to be the in between marmoset and like a human subject. What's the difference among them? So I think that this would be a good good things to talk together, I guess.
I think so. I want to say that the monkey is a more human side.
Could be.
But another interesting is that frontopolar cortex is maybe in the marmoset very tiny the frontopolar cortex there, and then the macaque monkeys have the moderate size, and the human is very big. Yes, and then some my mentors Matthew Rushworth thinks that some part of the frontopolar cortex in the human has no counterpart in the monkeys. They are very robust, but frontopolar cortex is well preserved across the subjects as compared to the another area like temporal parietal junctions, like that. But for the temporal parietal junctions, is monkey is missing, and some functional counterpart is in the middle, the STS. But in the ape, there is some functional counterpart of this TPGA is improving. So this some difference, and in some evolution. It's quite important to think about some difference of their first behavior, and then some of the type of the society, of the type of the groups of the monkeys, apes, and humans. So I think that to collaborate with the people with using the different type of animals and humans is very good to collaborate, and then to understand neural circuit, that generate different types of behavior.
Thanks a lot. That'd be brilliant. Right. So so I'll check that. So maybe I had enough questions, but maybe other people still have questions. If not, maybe we can close now. So discussion session will be just off recorded, so we don't open. So only talk, your talk part will be
okay.
Please let me know if you have some part you don't want to. Don't want to open. I'll send you emails to.
I'll send you my request. Sorry. And maybe some people that stay left in this conversation. I'm very I want to say very thank you to stay in this session, and please contact me if you are interested in our research, and then I'm very happy to discuss with you or do something, do some collaboration. And yeah, my lab is very open, and then I want to collaborate and communicate with you, in the future.
Okay, yeah, thanks a lot again for the great talk and like long discussion. This is very exhausting, I know. So, but yeah, so we keep having this kind of event, and next time, another speaker from RIKEN also she's gonna talk. Yeah, you can also watch. Yeah. So Tamaki-san will. She's gonna talk about the sleep studies.
Nice.
Yeah. So. Okay, yeah, thanks a lot again. And we will close this session. Thank you for joining us today.
Thank you so much for inviting me. Okay,
see you.